To be able to show what's happening in a chemical reaction, you need to understand chemical equations. One way to show a reaction is with a word equation. Imagine we're told that methane burns in oxygen, turning into carbon dioxide and water. On the left-hand side of our equation, we have the methane and oxygen that reacted together, and we call these the reactants. On the right, we have the molecules that are produced. So in this case, carbon dioxide and water, which we call the products. And in the middle, we have a single arrow to show that the reactants react completely to form the products. More often though, instead of writing these word equations, we write symbol equations, using the chemical symbols of each molecule involved. So we would have CH4, which is methane, plus O2, going to form CO2 plus H2O. Notice that I've put O2 rather than O. That's because oxygen exists as a molecule made up of two atoms. So whenever you include oxygen in a reaction, you have to put O2. Just like for chlorine, you'd put Cl2, and for nitrogen, N2. Anyway, getting back to our equation. It's not quite right just yet, because we haven't balanced it. In order to be balanced, chemical equations need to have the same total number of each type of atom on either side of the arrow. In our example, we can see that on the left of the arrow, there's 1 carbon, 4 hydrogens, and 2 oxygens, whilst on the right, there's 1 carbon, 2 hydrogens, and 3 oxygens. So our equation isn't balanced. Somehow, we need to increase the number of oxygens on the left-hand side, and increase the number of hydrogens on the right. Now, it's absolutely fine if you can't work out how to balance it in one go. Often, balancing equations is a process of trial and error, where you keep on changing numbers until you get the answer. The first rule of balancing equations is that we can't change any of the little numbers. This is because doing so would mean that we were changing the actual type of chemicals in our equation. For example, we couldn't change our O2 to an O3, because O3 is an entirely different substance, which isn't oxygen. Instead, we have to rely on changing the big numbers in front of the different elements or compounds, as this number just represents how many of that substance there are. So to increase the number of oxygen atoms on the left, we'd have to put a 2 in front of the O2, meaning we now have 2 oxygen molecules, and therefore 4 oxygen atoms in total on the left-hand side. This might seem a bit weird, as we only need 3 oxygen atoms to match the right-hand side. So shouldn't we just make it 1.5 molecules of oxygen? Unfortunately, we can't. When balancing chemical equations, another rule is that we need to keep to whole numbers. And so we have to round up to 2 instead, and keep 4 oxygen atoms. This leaves us needing 2 more hydrogens and 1 more oxygen on the right, which we can get by increasing the number of water molecules from 1 to 2. So we now have the same number of each type of atom on both sides of the reaction, and so we're done. Let's quickly try one more example. Sulfuric acid plus sodium hydroxide goes to form sodium sulfate plus water. On the left, we have 3 hydrogens, 1 sulfur, 5 oxygens, and 1 sodium. While on the right, we have 2 hydrogens, 1 sulfur, 5 oxygens, and 2 sodiums. Although it's up to you, I recommend balancing the least common elements first, which in this case would be sulfur and sodium. As sulfur is already balanced, with 1 on either side, I'd look at sodium, where we can see that we need 1 more on the left. So to fix this, I'd put a 2 in front of the sodium hydroxide, giving us 2 sodiums. Then if we count all of our atoms again, we can see that we need 2 more hydrogens and 1 more oxygen on the right-hand side. This is a pretty common problem to have, and we can fix it by adding 1 more water molecule to the right. As always, when you think you're done, just double check to see if it's balanced. So we've got 4 hydrogens, 1 sulfur, 6 oxygens, and 2 sodium atoms on each side. So this is exactly balanced, and we're finished.